All right, so this time a little bit different. We're going to do what's called solving linear inequalities. All right, so we're eventually going to solve polynomial inequalities, but we'll start off with an easier thing called linear inequalities, which just means our polynomials are going to have degree number 1 here. Just a little review, because this is something that when I was in school, we went through a lot with the greater than, equal to signs, less than, and equal to signs, but I find that's not as common anymore as it used to be. All right, so example number 1, we're going to solve the inequality. Now, I will tell you this is essentially what I'm going to do is act as if this less than sign is a linear, like an equal sign. So I'm going to treat it almost the same. And so the first thing I'm going to do is get, like I do with solving equations with equal signs, I'm going to get my x's to one side, my numbers on the other. And so in this case, I've got 9x minus 4 less than 6x plus 8. So I'm going to bring that 6x over to my other side here. And so again, changes sides, changes sign, whether it's a less than sign or an equal sign, still the same rule applies. All right, then I have a less than, which is great because it's actually on my keyboard. I have an 8 over there. All right, and I'm going to bring that minus 4 over to the other side here. And so I'm going to get 8 plus 4. All right, now I can simplify things here. And so 9x minus 6x is 3x. And again, that's going to be less than 12. Now, again, the whole key here is I'm going to get x by itself. So I'm going to divide by 3 on both sides. All right, and those 3's divide each other out. And what I end up with using set notation, we've had 2 different notations. And this is set notation. It's going to be x is just less than 12 divided by 3, which is 4. So again, nothing too crazy there. I'm just treating that less than sign as an equal sign. But things do get a little bit different. For instance, I get to example 2, where it's solve the inequality. 18 is less than or equal to 3 times x plus 7 less than or equal to 27. So I have a double inequality here. All right. So again, the first thing I want to do is simplify the middle of the inequality. And so I've got 18 is less than or equal to. And I'm going to do the rainbow rules, I call it here. Some teachers teach it as the distributive property. Students never remember that when I taught that, so I don't even bother. So the rainbow rule is 3 times x, I got 3x. And then 3 times 7, I got 21, positive 21. And again, that is going to be less than or equal to 27. Now, again, the whole thing here is that I'm going to get x by itself. So the first thing I'm going to do is subtract 21. Now, I'm going to subtract 21 from every piece of this inequality. So now what I end up with, if I take 18 and I minus 21, I have a minus 3. Is less than or equal to 3x. Again, 21 minus 21 is gone. So then I have less than or equal to 27 minus 21, which is 6. All right. Now, again, I'm trying to get x by itself here. And so I'm going to divide by 3. But again, what I do to the middle, I'm going to do it to both the left and the right. And so now what I end up with is negative 3 divided by 3 is negative 1. And that's less than or equal to, I've got my x. And less than or equal to 6 divided by 3, which is 2. And so again, using set notation, that's what we got going on here, is that negative 1 is less than or equal to x, but x then is less than or equal to 2. So that is solving the inequality, the bounds for x. All right, so let's change it up again. There's lots of different ways these things can look. So I got another inequality. Again, just a one-sided inequality, or it's a two-sided inequality, a double inequality, a single. This time I'm going to use what's called interval notation, which we've dealt with, but again, I will go over it. And so I got 3x minus 4 is less than or equal to 11. So again, I'm going to get x by itself here. So I'm going to move this minus 4 over to the other side. And so my inequality here is 3x less than or equal to. Now, if I move that minus 4 over to the other side, it becomes a plus 4. So 11 plus 4 is going to give me a 15. All right. Again, I got to get x by itself. So I'm going to divide both sides here by 3. All right. And so now I get x is less than or equal to 15 divided by 3, which is 5. Now, what I have right here is set notation. But we wanted an interval notation. And so for interval notation, that is when we use the round brackets and square brackets. And so this is saying x is less than or equal to 5. So that means our upper bound is 5. And because it's equal to, I've got a square bracket. All right, now on the lower end, it's everything. And so to say everything, that would be negative infinity. Everything left of number 5. Now, because negative infinity and infinity aren't numbers, you can't have them. And so I go a round bracket to say that they are, I guess, in terms of our number line, open circle. Because you can't have negative infinity. It's not a number. It's more of a theology, if you will. All right, so that's interval notation, and there is set notation. Two different notations going on there. All right, let's see, example 4. So again, here we're going to be looking for interval notation, but I have, again, a double inequality where I have less than and less than. All right, so here we go. So again, I'm going to simplify, first of all, what's going on here in the middle of my inequality. That's the first step. So I have 12 is less than, let's see, I got negative 6x. Then again, I'm going to do my rainbow rule here. So I have plus 3x minus 3. Again, that will be less than my 18. All right, so again, I'm going to continue to simplify what's in the brackets, or not in the brackets, but in the middle of my double inequality. So negative 6x plus 3x is minus 3x. And then I got minus 3, which again is less than 18. All right, so now again, I'm trying to get x by itself. That's the whole goal here. And so I'm going to get rid of this minus 3 by adding 3. But I'm going to have to do that to the right and to the left. All right, so now what I end up with is 15 is less than minus 3x is all that's left in the middle. And let's see, I got less than 18 plus 3, which is 21. Now, here's the catch. There's always a catch, isn't there? I got to get x by itself. I'm going to divide by negative 3. Which is probably hopefully no surprise. What I do in the middle there, I'm going to do on the left, and I'm going to do on the right. Now, here's the key here. Here's the trick, is that the inequality signs reverse if we multiply, because that can happen too, or more likely divide by a negative number, which I just did. All right, so if I'm dividing by this negative 3, so here's what happens now. 15 divided by negative 3, that's negative 5. Oops, negative 5. But that less than sign, both less than signs actually, because I divided by a negative number, or, you know, if you multiply by a negative number, it's going to switch to now greater than. All right, now I do have x in the middle because those negative 3's divide each other out. Again, 21 divided by negative 3 is negative 7. There we go. And now, because I got x by itself, I'm done. But again, this here is set notation. And we want interval notation. That's what we're looking for here. Now, it says we're between negative, x is between -5 to -7. Now, again, x is greater than -7, but less than -5. You got to remember that -7 is a smaller number or more negative, or how's this? Farther left on our number line. And so it's going to be -7, comma, to -5. Again, because we don't have equal signs here, round bracket, or in case of our number line, we would be looking at open circles. And there we go. So it's saying that x is between -7 and -5. And again, I put the negative sign, -7 first because it's farther left on our number line. All right. Example 5. Determine if -1 is a solution for the inequality -6 is less than 1/2 8x plus 4. All right, so I'm going to, first of all, solve my inequality here. And so I'm going to, well, first off, do the rainbow rule. Right, I got this half that I've got to multiply out. And so what I end up here with is I got -6 less than or equal to, let me see, I take half of 8x is going to be 4x. And half of 4 is a 2. All right, again, I want to get, this is a single inequality, so I want to get x by itself. So I'm going to subtract 2 from both sides. And so now what I end up with, let's see here, -6 minus 2, -8. Less than or equal to 4x. All right, again, getting x by itself. Let's see here. I'm going to divide both sides by 4. And I'm going to get, let's see here, -2 on the left. So keep my colors here. Is less than or equal to x. Which I could actually rewrite. This is what I love about inequalities and math. You can read inequalities left to right or right to left, because I could also write that as x is greater than or equal to -2. So determine if -1 is a solution for the inequality. Well, if x is equal to -1, well, -1 is greater than or equal to -2, just substituting into my inequality over here. And so, yeah, therefore, -1 is a solution. And the thing with inequalities is there's many, millions and millions of solutions. But we're just asking, hey, is this one a solution? Yeah, it is. So I solved the inequality, then plugged it in, and found out whether it was or not. All right, so let's see what else. I got a couple different things here going on. I'll try to throw the kitchen sink at you here. Oh, here's a double inequality, and we got some fractions on there. So it says solve the inequality right there. I'm not going to try to say that one out. And illustrate your solution on a number line. All right, so first of all, we got fractions. That's a problem. So I'm going to clear fractions first. Here's how I'm going to do it. I'm going to multiply, so it's a little grade 9 math, by the lowest common multiple of the denominators. What does that mean, right? That's a lot of math language. In other words, I'm going to multiply the lowest number, because we got our denominators here. I'm going to underline them first in green. 12, 3, 4, 12. Multiply by the lowest common multiples, which means what's the lowest number that 12, 3, 4, and 12 go into nicely? And in fact, the number that does go in nicely is 12, right? 12 goes into 12 clearly, nicely. What I mean by that is no decimals. 3 goes into 12 and 4 goes into 12. And that is the lowest number. 24 would work, right? But 24 is not the lowest number that they all go into. All right, so I'm going to multiply every term up here by 12. I wonder if I can copy that somehow. Let's see here. See if I can cheat. Nope. There we go. Nope, not let me do it. All right, so here's what's going to happen. I'm going to multiply every term by 12. You know what? I'm going to have to write it out. Here we go. So negative 1 over 12 greater than or equal to. Now this negative x, that's basically a negative 1x, or it is, not basically, plus 1/4 greater than or equal to negative 17 over 12. All right, so as I mentioned, I'm going to multiply every single term by 12. So this one by 12, fitting it in there, this one by 12, and the last one by 12. Every term I'm going to multiply by the lowest common multiple. All right, so here's what happens. In this case, I got a 12 on the top, I got a 12 on the bottom. They divide each other out. That's negative 1 now. And by multiplying by the lowest common multiple, again, it's going to get rid of all the fractions. Now, in this case, negative 1 times 12 is negative 12. Divided by 3, that's a negative 4. Plus, I got 12 divided by 4. Well, 1 times 12 is 12. Then divided by 4. That's a 3. I have a feeling I'm missing an x here, aren't I? Oh, yeah, this is negative 1x. I was wondering where my x went. Sorry about that. Throw that x in there. So that's a negative 4x. All right. Now, plus 1 times 12 is 12. Divided by 4 is 3. Greater than or equal to, let's see, negative 17 times 12 is some big number divided by 12. But I see a 12 on the top, 12 on the bottom. Gone. Minus 17. There we go. So now I just cleared fractions. So now I got a question like I had before, right? I have a double inequality where, again, I got to get x by itself. So I'm going to subtract by 3. And I'm going to have to do that on the left and on the right. And so negative 1 minus 3, that's a minus 4. Greater than or equal to, let's see, I'm going to have this minus 4x here. All right, and then, whoops, greater than or equal to, because these 3's are gone. 3 minus 3 is 0. That's why we did it. And then minus 17 minus 3, minus 20. All right, so here's where we're at. Now I got to get x by itself. I'm going to have to divide by negative 4. Looks like I changed this question for my formula sheet or my notes. So if I'm going to divide both sides by minus 4, or in the middle I'm going to divide by 4. On the left I'm going to divide by minus 4, and on the right I'm going to divide by minus 4. All right, now negative 4 divided by negative 4 is positive 1. Whoops, let's use the same color here. Now I divided by a negative number. So that means the greater than or equal to sign becomes a less than or equal to sign. Negative 4 divided by negative 4, I'm just going to be left with an x here. And again, this greater than or equal to sign becomes a less than or an equal to sign. It switches. And then minus 20 divided by minus 4 is 5. All right, now how do I express this? Because this says saying do this on a solution on a number line. 1 is less than or equal to x, which is less than or equal to 5. Well, I'm going to need a number. I'm going to need a line. I'm going to use my little line here. There we go. All right, let's see here. So 0's in the middle. Well, I'm going to cheat and put it over on the left. I have a number of 1 on the left, so that's a 1 there. Let's say a 5 right here. All right, so you can make your guesses where to. It's just a sketch. It's 1. X is between 1 and 5 and include. So because it's equal, I got a closed circle on both ends here. And there is my solution expressed on a number line. Now, I could also express this in interval notation by going square bracket 1, comma 5, square bracket. Again, the square brackets indicate the equal signs or the closed dot. It includes it. So there we have set notation, interval notation, and the solution on a number line. Again, I think I changed this example. I got to fix that, but I think I took the negative sign out on the answers I put in, or my different note. Sometimes I update my notes, change it up. I like to show you everything. All right, now the last one. The relationship, I love this one, between Celsius and Fahrenheit is represented by the equation F equals 9/5 Celsius plus 32 degrees. Now, this is kind of an interesting thing that I've learned, is that Celsius and Fahrenheit, we have two different ways of measuring temperature. And I always wondered what's the difference, because Celsius here, we do that in Canada, and Fahrenheit, they do that in the United States. Celsius, 0 degrees Celsius, is the freezing point of water. Fahrenheit, 0 degrees Fahrenheit, is the freezing point of salt water, brine water. So that's the difference. I didn't know that until last year. It's kind of cool. Now, the daily temperature in Las Vegas, I believe this is true. I did my research here. Ranges from 78 degrees Fahrenheit to 114 degrees Fahrenheit. And I've experienced 114 degrees Fahrenheit in Las Vegas in the bottom of the Grand Canyon. Now, it says, write this statement as a double inequality. Okay, well, it says the daily temperature is 78 degrees Fahrenheit to 114 degrees Fahrenheit. Well, as a double inequality, 78 degrees is less than, and it can be 78, equals to the Fahrenheit, which is less than or equal to 114. Now, Fahrenheit, there's our formula there. So I could actually also express this inequality as 78 degrees Fahrenheit is less than or equal to 9/5 Celsius plus 32, which is less than or equal to 114 degrees. That's another way of expressing that inequality in terms of Celsius. So I've expressed the inequality twice. Once we're talking about Fahrenheit, the other one talking about Celsius. Now it says, solve the inequality, determine the temperature range in Celsius. So what I'm going to do is take my second inequality and solve for C and find out what the range of the summer temperatures are in Las Vegas, but in terms of Celsius, Canadian. All right, so I'm going to take my, whoops, I want to let me capture, no? All right, let's go. All right, so I'm going to take my inequality here. There it is. All right, I'm going to solve it for Celsius just to see what our range in Las Vegas would be in terms of talking about Canadians. Now we have a fraction, right? And I'm going to clear the fractions by multiplying by the lowest common multiple of all the denominators. Well, I only have one denominator. So I'm going to multiply, and my denominator is 5 here. So the lowest common multiple, if there's only one, then it's got to be it. So I'm going to multiply every term by 5. So I'm going to have to squeeze a 5 in here. All right, I'm going to have to multiply that 32 by 5. Let's see here. I got 14. I'm going to have to multiply, well, 114. I'm going to have to multiply it by 5. All right, so out comes a calculator here. Let's see here. 5 times 78 is 390. Okay. It is less than or equal to, let's see here. Now, I've got 5 times 9, which is 45, divided by 5 is 9. So I got a 9C here. Plus 32 times 5. It's 160. All right, is less than or equal to 114 times 5, which is a huge number. It's 570. All right. So again, I'm solving my inequality, getting C by itself. So I'm going to subtract 160. What I do to one side here, I'm going to have to do to the other. All right, so 390 minus 160, I believe, would be 230. Is less than or equal to 9C. I got 160 minus 160. It's gone. That was the whole point. Less than or equal to 570 minus 160, which would be 410. All right, now my last step, I'm going to subtract, or sorry, not subtract. I'm going to divide by 9, positive 9, so my signs aren't going to switch here. And I'm going to have to do the same thing on the left and the same thing on the right. All right, so now I'm going to get my inequality. Let's see here. I get 230 divided by 9. So the low end, let's see here, is 25. Go to 2 decimal places here, 56. Less than or equal to C, because those 9s divide each other out, which is less than or equal to, let's see, 410 divided by 9. And I get 45.56 degrees Celsius. So what that's saying is, we just solved that inequality, is that in Vegas, if you're the Americans would talk about Fahrenheit, that the average Vegas summer temperature goes from 78 to 114 degrees Fahrenheit. But if we're talking about in Canada, and again, I believe these values are true, I did the research here, is that the average summer temperature is between 25.56 degrees Celsius and 45.56 degrees Celsius. So that is very hot. Now, if you've ever been out west in the United States, like Vegas or California, because Vegas specifically is in the desert, it's different heat. It's dry. It's actually having like dry heat on you, like a hairdryer on you. So the heat's much different type. And the other interesting thing about Las Vegas is it's kind of funny is that, number one, there's no grass other than golf courses. And number two, we have pools in Canada that we have regular pools and we have pool heaters. In Las Vegas, they have regular pools and they have chilled pools. So you have pool coolers on the side of their houses. So everything's the opposite. The other cool thing is in Las Vegas is when you're talking about